Hey guys, it's Mr. C, and in this video we're going to look at solving some inequalities. And so I guess the first thing we should talk about is what is an inequality before we get into this problem. Inequalities have symbols, not an equal sign. Equals is for an equation. There is less than or equal to, greater than or equal to. So we have those four symbols that we're going to see. We're not going to see this one for an inequality, and so for an equation. And so for an inequality, so we're not going to see the equals for an inequality. So these four right here, what happens is instead of getting one answer or two, you get a whole span of answers. And then possibly you could have no answers, or you could get all real numbers. It just depends on how this inequality is structured over here from the beginning. And so each time I'm going to be talking about the symbol, and we'll be solving it and graphing it each time so we can see a visual picture of what the solution set's going to look like. All right, so we got 2x minus 5 is greater than 7. This would be a two-step equation, and we're going to solve these a lot like equations, with one exception, which I'll get into here in the next example. The first thing you would do if this was an equation is you would add 5 to both sides. No problem, right? We all know that. You bring down your 2x, greater than 7 plus 5 is 12. And then you just divide by 2, no problem, just like an equation. And x would be greater than 6. Well, what that means is all real numbers bigger than 6. So that's a lot of numbers. All right, so first of all, let's go ahead and write that as a set builder in set builder notation. So it would be curly bracket, all x such that x is greater than 6. And then you put another curly bracket on the other side. So for me, either one of these is okay, but this is really the one that we want to get to, because that's more of the algebra 1, a little bit of algebra 2-ish kind of notation there. Now let's look at the graph. And so we're going to graph this thing, and I'm going to put the graph down here, doesn't matter. And on your graph, your number line, you want to show all the numbers that can satisfy this, that would make this original inequality a true statement. And so we only have one solution here, x greater than 6. Well, not one solution, but one starting point, 6. So we put that right in the middle. It is a greater than symbol, and when you see a greater than symbol like this, it's going to be an open circle on the graph. Same thing if it was this one, it'd be an open circle on the graph. If it was less than or equal to or greater than or equal to, then those would be closed circles on the graph. You may have been told that already or may not. So we want all real numbers bigger than 6. And so what's going to happen is we're going to go this way to the right, and those are all the real numbers bigger than 6. And then that's what your graph looks like. There's no sense in putting all the numbers on here when the only one I really need is 6. And most professors do it the same way. All right, this one says 3 minus 4x less than or equal to 7. And so this time, I'm going to go ahead and subtract 3 on both sides. Bring down my minus 4x or negative 4x less than or equal to, then that would be 4. And now I'm about to do something interesting. I'm about to divide by a negative 4. So here's a key point. When you multiply or divide both sides, multiply or divide only, not add or subtract, multiply or divide by a negative, you're going to flip the symbol after you do that. So these two cancel. X greater than or equal to 4 divided by negative 4 is negative 1. If you forget to flip that symbol, your solution set will not be true when you plug those numbers back in up here for x. So that would be curly bracket, all x such that x is greater than or equal to negative 1. Close it up. I'll show you an even easier way here in a little bit to do that. Okay, so our number line then for this one, the only number I really have to have on there is negative 1. Our starting place, and it is greater than or equal to, so I'm going to put a closed circle on negative 1, and I'm going to shade that to the right to show all numbers bigger than or equal to negative 1. So when you go to the right, those are bigger numbers. When you go to the left, those are smaller numbers. Okay, this time 3x plus 2 less than or equal to 7x. We are going to get variables on both sides, so let's see how that works. If I subtract 3x on both sides, because I do have variables on both sides, I get positive 2 less than or equal to 7 minus 3 is 4x. If I divide both sides by 4, I get 1/2, 2 over 4 is 1/2, less than or equal to x. I really want that x to be on the left-hand side when I graph. And so what I do is I take the whole thing and I twist the whole thing around like this, including the symbol, and I write actually x greater than or equal to 1/2. And if you plug in to here any number bigger than or equal to 1/2, here and here, it should be a true statement. All right, so that would be all x such that x is greater than or equal to 1/2. So we like an inequalities for our variable to be on the left-hand side. For equations, it doesn't really matter. But for inequalities, it just kind of helps us see what's going on better. So now the only number I have to have on there is 1/2. It is greater than or equal to, so that would be a closed circle. And if the variable's on the left, let's use the arrow to determine which way we shade. And so we're pointing to the right, so we're going to shade to the right. So if the variable's on the left-hand side, we can really use that symbol to determine which way to shade. All right, here we have another one. And this time I'm going to subtract 3x on both sides because I do have variables on both sides. And we're solving this just like an equation. Minus 4 greater than or equal to 4 take away 3 is 1, x plus 1. Subtract 1, and we have negative 5 greater than or equal to x. But again, I want that x to be on the left, so I'm going to twist everything around, and I'm going to write it as x less than or equal to negative 5. So that would be curly bracket, all x such that x is less than or equal to negative 5. All right, so now we're going to graph it. On my graph, the only number I have to have on there is negative 5, right in the middle. It is going to be a closed circle, because I do have an equals part on there. And since the variable is on the left, and the arrow is pointing to the left, I can shade to the left. And just shade that real good like that. Put your arrow on there, and that one is done. Okay, this time, we got 6x plus 2 less than 2x minus 1. So again, we have variables on both sides. So I'm going to take a 2x away on both sides to get it going. 6 minus 2 is 4. Plus 2, strictly less than negative 1. Now I'm going to subtract 2 on both sides. Bring down my 4x less than negative 3. And I'm going to divide by 4. And I get x less than negative 3/4. So now, to write my set builder notation, just put a little line there with the variable right next to it, and close it up with some curly brackets. It's a little easier way to do it. All right, let's graph this thing. So it looks like the only number I need on there is negative 3/4, right in the middle. I am looking at all numbers less than, so it is an open circle, strictly less than, and we're going to be shading to the left, just like that. All right, so here we have this one. So we see already that if we have a hard time solving linear equations like this, we're going to have an extra hard time with the inequalities. So we definitely have to be good with the equations. I'm going to add x to both sides, see what happens here. So I got negative 4 greater than 3 and 1 make 4x minus 2. I'm going to go ahead and add 2 to both sides. And I've got negative 4 plus 2 would be a negative 2, right? Greater than 4x. So let's divide by 4 on both sides. And we've got negative 1/2 greater than x. Let's twist that whole thing around. And let's make it x less than negative 1/2 instead. Then we're going to turn it into our set builder notation. And if you have a hard time with the set builder notation with these curly brackets, just remember it's an S and a backwards S underneath. Over here it's a backwards S, then a forwards S down there. You got to practice that a little bit sometimes. All right, so let's talk about our graph. Our graph needs -1/2 to be right in the middle. And we are less than strictly. So that's an open circle. And we're going to shade to the left. And then there's our graph. All right, so some of these problems we have to do a little bit more work, like this one. So this one, we have to, on this side, distribute first before we can get it going here. So we got x plus 3 less than or equal to 2x. And then 2 times -4 is -8. Now we can get it going. I'm going to subtract x on both sides. Bring down my 3, less than or equal to positive 1x minus 8. Let's add 8 to both sides. 8 plus 3 is 11, less than or equal to x. And so if we twist that around, we're going to get x greater than or equal to 11. So let's do our set builder notation. I'll use a different color this time to show you, to reinforce that. Just put a line right there. That means such that. There's your variable, all real x, curly bracket, curly bracket. And so this just means the solution set is all real x, such that, that's a condition, such that x is bigger than or equal to 11. All right, so now, let's go ahead and graph that. So we've got an 11 right in the middle. We are all numbers bigger than or equal to, so we're going to have a closed circle, and it's going to be shaded to the right. And then there's our arrow. Okay, this example, again, I need to distribute that 7 first before I do anything. So I'll just bring down the 2x plus 10 greater than or equal to 7x. And 7 times 1 is plus 7. And then we take it from there. Minus 2x. Minus 2x. Drop down my 10. Greater than or equal to 7 minus 2 is 5. 5x plus 7. And then we subtract 7 on both sides. 10 take away 7 is 3. And then we just divide by 5. And we got 3/5 greater than or equal to x. And so we twist all of that around, and that would be x less than or equal to 3/5. It's the same thing. And then we're going to turn that into some set builder. So you put your line there, put your x on the other side, curly bracket, curly bracket. So solution set for the graph. See what this looks like. Okay, so this time I need 3/5 in the middle. And I need a closed circle. And I need everything less than or equal to, so we're going to shade to the left. Just like that. And that one is done. Again, another one with some distributing first. So we need to distribute. Drop down my negative x plus 4 less than 2x. And then that would be a minus 16. All right, start moving stuff around. Plus x. Drop down my 4 less than 2 and 1 make 3x. Minus 16. And let's add 16 to both sides. Those cancel. 16 plus 4 is 20. Less than 3x. Divide by 3. And we have 20 over 3 less than x. Again, we have to twist everything around. X is greater than, just flip the symbol, 20 over 3. And we turn that into our set builder. Again, those curly brackets sometimes need practice if that's the first time you're ever doing it. And let's take a look at our graph. All right, so we need 20 over 3 directly in the middle. We don't really need to know what that is as a decimal, just needs to be in the middle. We have an open circle, and we are shaded to the right. Again, as long as our variable's on the left, we can use that arrow to determine which way to shade on the number line. All right, this time we need to distribute a negative to both of these. When you distribute a negative, all it does is change the sign of it, of each item. Negative x plus 6 greater than negative 2x. And then negative and positive make negative when they're multiplied, so minus 4. So this time I'm going to add 2x to both sides. 2 and negative 1 make 1 plus 6, still greater than negative 4. I'm going to subtract 6, subtract 6. These guys cancel, and x is greater than negative 10. So we're going to turn that now, since x is already on the left. We don't have to twist it. Turn that into some set builder. Get you guys used to that. And that's what that looks like. Now we'll go ahead and graph our solution set. So we need a negative 10 in the middle. And it's an open circle again. And it's shaded to the right. And that's what our graph looks like. All right, this time we've got to distribute over here first. Negative 2x. Negative 2 times 3 is negative 6. Less than 4x minus 7. All right, so I'm going to add 2x to both sides. I always do this so that I get a positive result on one side or the other, and I do. Negative 6 is less than positive 6x minus 7. Add 7. And 7 and minus 6 makes 1, less than 6x. I got to twist everything around again. Oh, wait. No, before I do that, I have to divide by 6. Let's wait. So I have 1/6 less than x. A little premature on that one. Now I twist it around. So x is greater than positive 1/6. All right, so now let's turn that into some set builder. Curly bracket, curly bracket. And the graph looks like I need a 1/6 right in the middle. I need an open circle, and I'm shaded to the right. Okay. So now let's take a look at some graphs and see if we can make the correct inequality from it. Here we have all numbers less than negative 6 and not including negative 6. So if you want to write an inequality for that, that would be x strictly less than negative 6. That's all numbers less than negative 6, and that's exactly what that says. And then we'll turn it into some set builder notation, just like that. Here, if we read the graph, we see we have all numbers from negative 2 on up. So that'd be all real numbers greater than negative 2, greater than or equal to negative 2, because it's a closed circle. That is definitely a closed circle right there. Greater than or equal to negative 2. So all x greater than or equal to negative 2. And let's put that into set builder notation. And then we're done with that one. Here we have all real numbers less than or equal to negative 5. And again, we do have a closed circle there. So all x less than or equal to negative 5. Set builder, set builder. That was a pretty bad looking curly bracket, but it'll work. And that's it for that one. And then we have an open circle, which is what this is supposed to be. Open circle from 3 on up, 3 or greater. X greater than, strictly greater than 3, And then we're going to turn that into set builder. Curly bracket, curly bracket. And that's it for solving inequalities. Remember to like my video and subscribe to my channel. And we'll see you guys later. Bye.